Okay, now let's start the block 1, where we are going to talk mostly about methods for describing and investigating the behavior of random values. That's the plan for the first lecture. We will start with some general things, what we are working with, what variables are, what is a population and sample, and so on, and then eventually learn some simple methods and plots for describing your data. Well, first of all, what data is? Data usually is a result of your measurements or observations. So, for example, you have some individuals and you have some characteristics or variables you want to measure. Individual means some real objects or phenomena. It can be a person, it can be an animal, it can be anything actually. And then the variable is some property or characteristic or several characteristics you are interested in and you want to measure or observe. You remember the people data we used for the exercise last time? It's a very good example of what experimental data may look like. You have objects, you have 32 persons as objects, and you have 12 different variables to measure or observe. In our case, we have objects as rows. We have 16 males, 16 females, 16 Scandinavians, and 16 Mediterraneans, 32 persons. And then we have 12 different variables. We have height, weight, hair length, and so on. And if you look at the variables, if you look at the units we use to measure the variables, you will see that they are quite different. For example, height is measured in centimeters. It varies from 120 to 200. Then we have weight measured in kilograms. Hair length is a different one because it's a coded variable. So you have two numbers, -1 and +1. -1 is for short hairs and +1 is for long hairs. Then we have shoe size. It's a EU standard shoe size. We have age in years, we have income, it's amount of euro per year, we have beer consumption and wine consumption, it's a number of liters a particular person drinks a year. Then we have sex, again it's coded variable, -1 for males and +1 for females. We have swimming ability and we have region, again coded variable, -1 for Scandinavia and +1 for Mediterranean region. Finally we have IQ, it's a result of standard EU test. You see that variables are pretty different. And of course, methods that we are going to use for analyzing these variables will be different as well. Let's talk about these types of variables or categories of the variables. Well, there are several different categories. In the simple form, we can tell about discrete and continuous variables. We can talk about quantitative and qualitative variables, and random and deterministic. So let's discuss that. The discrete variable is a variable that can take only a finite number of values, while continuous variables may have infinite amount of values. So, for example, if you think about amount of children in a family, it's clearly a discrete variable because it cannot have infinite amount of values, right? So you may have 0, no children. You may have 1, 2, and 3. Sometimes 4, sometimes 5, 10 probably, which is very rarely, but still the amount is fixed. The amount is finite. But if you, for example, talk about height of values, if we measure a height using a very precise method, for example, in micrometers, so the amount is almost infinite. Of course, in real measurements, for example, if you measure height in centimeters, the amount is still limited because of the precision of the measurements. But this amount is large enough so we can treat this variable as a continuous, and that's what we are going to do in most of the cases. And several more examples, for example, length of hairs. If you measure them in centimeters or millimeters, it's apparently continuous variable. Number of children in a family, as we discussed, is a discrete variable. Then you can think about temperature. Again, if you measure a room temperature, let's say in degrees, in Celsius degrees, without decimals, then of course it is discrete because we have some limited amount of values, let's say from -40 to +40, 81 values. But the amount is big enough to treat this variable as a continuous variable. If you use decimals, you have even more values. Okay. Number of people in a room. In this case, again, we have a discrete variable because room has some limited volume. For example, a room may have only up to 20 persons, so it means that the amount of people in the room is fixed. It's between 0 and 20, so it's 21 values. So in this case, it's a discrete variable. Okay. Quantitative and qualitative. Well, that means a very simple thing. If a variable describes a category, it's a qualitative variable. If a variable describes an amount, it's a quantitative variable, quantity. or quality. Sometimes qualitative variables are called categorical variables or factors. Okay. These categorical variables can be ordinal or non-ordinal. Ordinal means you can order the values. Non-ordinal means you cannot order the values. Well, this means the following. Even categories can be described by numbers. For example, if we talk about gender, we have males and females. We can assign 1 to males and 2 for females. So we have two numbers, 1 and 2. Of course, mathematically speaking, you can order it, but it will not make sense because, well, we can't order the genders, right? While males should be first and females should be last, or vice versa. So in this case, it's non-ordinal variable. But let's say we are talking about height of people, and we, instead of using centimeters, we use some categories, for example, small, medium, and large. In this case, we have categories, but at the same time, even though we use some numbers for like 1, 2, 3, we can order them, and it will make sense because, for example, 2 is larger than 1. It means that these peoples are higher than those peoples that are from the first category. So in this case, we deal with ordinal categorical variable. And I can show a couple of more examples. For example, color of eyes. It's a typical categorical variable, especially if you use words for defining the color, like brown or blue. This is categorical and it cannot be ordered. The third subtypes, it's random and deterministic. The idea is following. Variable is random if the value is assigned by a chance, random chance. So you cannot predict the value. And variable is not random if this value can be predicted, can be determined. This is a very interesting question because if you think about, let's say, height, is it random or deterministic variable? Well, you always can say, I know my height, so it's deterministic. But it's not, because height is a category for a lot of people, for a big amount of people. In this case, it's a random variable because you cannot predict it. For example, imagine that you wait for a baby, and can you say what height the baby will have after, for example, 10 years? You can't. It's not possible because there are so many random factors that influence height or weight of people. So these variables are absolutely random. And you can think about deterministic variable, and most of the time it will be variables that we define ourselves. For example, let's say number of days in a year. It's 365, sometimes 366. So it's a deterministic variable, but it's something that we have invented actually. In nature, we have either constants, which is not variable at all. For example, number of heads. It's always 1 if person is alive, right? So it's deterministic, but it's not variable because it does not vary. So it's always 1, it's fixed, it's constant. So most of the deterministic variables are the ones that we have defined ourselves. And then if we get back to our people data, we can think now what variables we have. Height and weight, apparently they are continuous. Strictly speaking, they are not, because we measure height in centimeters and weight in kilograms. We don't use decimals. So strictly speaking, we have a finite amount of values, but we can deal with them as a continuous variables. Hair length, it's ordinal, categorical or qualitative variable. Categorical because it's a category, short or long hairs. Ordinal because we still can order it because -1 means short, +1 means long hairs, and then it's very natural to have -1 first and +1, and then +1. Then shoe size. It's discrete variable, apparently. The smallest shoe size, as far as I remember, is 14 for babies, and largest is like 49, I believe. So it's a finite amount of values. But again, in some cases, we can treat shoe size as a continuous variable. The same about age. Income, we have a bigger amount, so we can treat it as a continuous, definitely, as well as beer and wine consumption. Sex, apparently it's a categorical, it's qualitative variable. We cannot order it, so it's non-ordinal categorical variable. Swimming ability, again, because it's an index between 0 and 100, so it means that it has finite amount of values, but the amount is large enough to treat it as a continuous. Region is, again, as a sex, it's non-ordinal categorical variable, and then IQ is a quantitative variable.